we are back with our classes on electricity in physics. We had done till Joule's law of heating. So we will revise Joule's law of heating, where we say that a part of electrical energy is converted into heat energy. We said that Joule's law of heating states that the heat developed in a conductor is directly proportional to I square, where I is current in amperes. It is directly proportional to the resistance of the conductor, where R is resistance in ohms, and where heat produced is directly proportional to the time through which it passes. So H is proportional to what? I square RT. This is what is the derivation, this is what is Joule's law of heating. How did we derive or come to the conclusion? We say V is equal to W by Q. So W is equal to what? VQ. From where did we derive this? From the definition of potential difference. What is I? I is equal to Q by T. So Q is equal to what? IT. So W is equal to what? VIT. This is one form of heat. So work done is nothing but heat energy. So H is equal to what? VIT. Now according to Ohm's law, V is equal to what? IR. So H is equal to IR into IT. So H is equal to what? I square RT. We also know that V is equal to IR. So I is equal to V by R. So H is equal to V square by R square into R into T. So H is equal to what? V square by R T. So these are the formulas of the heat developed in a conductor. H is equal to VIT. This is first formula. H is equal to I square RT. Second formula. H is equal to V square by R into T. Now let us read through practical applications of heating effect of electric current. Lot of reasoning questions will come from this. The generation of heat in a conductor is an inevitable consequence of electric current. In many cases, it is undesirable as it converts useful electrical energy into heat. In electric circuits, the unavoidable heating can increase the temperature of the component and alter their properties. However, it has many applications. The electric laundry iron, the electric toaster, the electric oven, the electric kettle, the electric heater are some of the familiar devices working on Joule's heating. Clear? So examples where you can use all electrical devices use generally Joule's law of heating. The electric heating is also used to produce light as an electric bulb. Here the filament must retain as much of the heat generated as is possible so that it gets very hot and emits light. It must not melt at such high temperature. A strong metal with a high melting point such as tungsten is used for making filaments. The filament should be thermally isolated as much as possible using insulating support. Please write. Why are the filament of bulbs made from tungsten, or why is tungsten used? Why is tungsten used as filament in electric bulbs? Why is tungsten used as filament in electric bulbs? Okay, these answers are there in the notes, but I am still telling you. See, the answer to this is tungsten is a metal which has a very high melting point, that is 3380 degrees centigrade. So it does not melt at very high temperature. It does not oxidize or break down into other components at a high temperature. So we use what? Tungsten as a filament in electric bulb. Next question, Bariday. why bulbs, electric bulbs are filled, why electric bulbs are filled with nitrogen and argon. With nitrogen and argon. We have studied nitrogen is an inert gas, even argon is an inert gas. Why it is filled with it? So that the tungsten filament life can be increased. Please underline there. The bulbs are usually filled with chemically inactive nitrogen and argon to prolong the life of a filament. Most of the power consumed by the filament appears as heat, but a small part of it is converted into light. So let us understand. If you have seen, generally inside the bulb, you will see there will be a filament like this. All of you would have seen. Okay, this filament is what filament? Tungsten filament. Why is tungsten used? Because it has high melting point. Second, it does not oxidize at high temperature. It does not oxidize at high temperature. So, what filaments are used? Tungsten filaments are used. These bulbs, if you look into it like this, these bulbs are completely filled with what gas? Argon or nitrogen gas. Why are they filled? So that the filament, the life of the filament can be increased, as it creates what atmosphere? An inert atmosphere. Understood this? All the questions answered. Tungsten filament is used because it has high melting point of 3380 degrees centigrade and it does not oxidize at high temperature. It is filled with argon or nitrogen gas. This is because they are what gases? Inert gases, and increase the shelf of tungsten filament. Another common application of Joule's law of heating is fuse in the electric circuit. All of us know what is fuse. Okay, fuse basically is a small what-shaped wire? S-shaped wire which is connected in the electrical circuits. Okay, this fuse wire is basically made up of a very thin wire and it is generally put like this. It is always connected in what? It is connected in series. When there is a sudden voltage fluctuation, you all know what is voltage fluctuation? When there is voltage fluctuation or some unnecessary current exceeds in the circuit, the fuse wire heats up and it melts and breaks the circuit, so that all the other appliances which are connected to the circuit does not get damaged. So fuse is called as what device? Safety device, because it melts and breaks the circuit and prevents all the other electrical appliances from further getting damaged. How can I find out fuse? Fuse generally have value as 1 ampere, 2 ampere, 4 ampere, 6 amperes, 10 amperes, 15 amperes. So now if I use the formula V is equal to IR, I will find out current. If the current in the circuit is 4 amperes, I will put a fuse of 5 amperes. So that even if it is used for a long duration of time, it should not melt. So I will slightly use a fuse of a higher value so that it can sustain the circuit. Now, it protects circuits and appliances by stopping the flow of an unduly current. The fuse is placed in series with the device. It consists of a piece of wire made up of an alloy or a metal of appropriate melting point. Aluminium, copper, iron, lead. If a current larger than a specified value flows through the circuit, the temperature of the fuse wire increases. This melts the fuse wire and breaks the circuit. The fuse wire is generally encased in a cartridge of porcelain or similar material with metal ends. The fuse used for domestic purposes are 1 ampere, 2 ampere, 3 ampere, 5 ampere, 10 ampere. Understood? From the starting point till there, please write how is fuse a safety device, or why is fuse called as a safety device? Why is fuse called a safety device? Full bariಬೇಕು ಅಷ್ಟುನು, but main answer ಏನು? Fuse is called as a safety device because if a current of a certain value exceeds in the circuit, it gets heated up. It melts, breaks the circuit, and thus protects the circuit from other damages. Okay? How to calculate fuse? The last part is very important. For an electric iron which consumes 1 kilowatt electric power, ಇದು ನಾವೇನು ಮಾಡಿಸ್ತೀನಿ because power ಗೊತ್ತಿಲ್ಲ ನಿಮಗೆ. So after studying power we will do that part. Okay? So what are the two ಇನ್ನೊಂದು question ಬರಲಿ. What are the different applications of Joule's law of heating? What are the different applications of Joule's law of heating? So you will write electric toaster, electric geyser, whatever, they all work on Joule's law of heating. That last line of the first paragraph. Second, tungsten filament used in bulbs. Third, fuse. Artha aita? First point ಏನು ಬರ್ತೀರಾ? Electric kettle, electric geyser, electric heater, all those works on Joule's law of heating. Second, tungsten filament is used in electric bulbs because in filament what? A part of heat energy is converted into light energy and hence the bulb glows. Third part is electric fuse. Fuse is a safety device which is always connected in series and is made up of a wire of a metal or an alloy. The metal can be copper, aluminium, lead, something is given. Clear? Understood this? Now we will start with what? Electric power. I am telling power, but please write power. So electric power. Last year ಓದಿದ್ದೀವಿ 9th ಅಲ್ಲಿ. What is power? Work done per unit time. So here we are not talking about work done, but we are talking about what? Electrical energy consumed. So electrical energy consumed per unit time is called as what? Power or power. Okay? Energy is measured in joules. Time is measured in seconds. So power is generally measured in watt on the basis of James Watt steam engine. Okay, so 1 watt is equal to 1 joule by 1 second. So SI unit of power, watt. How do you define? When 1 joule of electrical energy passes through a cross section of a conductor in 1 second, it consumes a power of 1 watt. You can define this also. Okay, but your question, according to your textbook, how it defines it as P is equal to E by T. So see, what was E equal to? VIT. Work done on heat was equal to VIT. So VIT by T. So P is equal to what? VI. P is equal to I square RT by T. So P is equal to what? I square R. P is equal to what? V square by R into T by T. This T and T gets cancelled. So P is equal to what? V square by R. Artha formulas. P is the 4 formulas of power. P is equal to E by T. P is equal to VI. P is equal to I square R and P is equal to V square by R. What is given, depending on that you will substitute. How do you define power? You define power using this formula. P is equal to VI. V is potential difference in volt and I is current in ampere. When a current of 1 ampere flows through a cross section of a conductor having a potential difference of 1 volt, it has a power of 1 watt. When it has a current of 1 ampere flowing through a cross section of a conductor having a potential difference of 1 volt, it establishes or it has a power of 1 watt. Clear? So what is power? Electrical energy consumed per unit time or energy consumed per unit time, because here we are using what energy? Heat energy. So P is equal to E by T, P is equal to VIT by T, P is equal to I square RT by T, P is equal to V square R by T. So all these are formulas of power. What is the SI unit of power? Watt. How do you define watt? When 1 ampere of current flows through a cross section of a conductor having a potential difference of 1 volt, it establishes a power of 1 watt. Now, larger units of power. One kilowatt is equal to 10 to the power of 3 watt. 1 megawatt is equal to 10 to the power of 6 watt. And if you go and see your motors and all, it is sold under what unit? Horsepower, HP. So 1 horsepower is equal to what? 746 watt. So these are all units of watt. Okay, or larger units of power. Now, commercial unit of power. We all know we get electricity in the form of units. So, what is our commercial unit of electrical energy? Commercial unit of electrical energy. Commercial unit of energy or electrical energy is generally what? Kilowatt hour. It is generally what? Kilowatt hour. Some books write it like this also. Kilowatt hour. So, what is the relationship between kilowatt hour and joules? Last year was there. 1 kilowatt hour is equal to 1 kilowatt into 1 hour. 1 kilowatt is 1000 watts and 1 hour is 3600 seconds. So it is nothing but 36 into 1, 2, 3, 4, 5. 10 to the power of 5 joules. How I got joules? What did I write? P by T is equal to P. That is joules by second is equal to watt. Watt is equal to joule by second. Energy, joules. This is equal to watt into seconds. So I converted kilowatt to watt. Hour to second. So that I get the answer in joules. So now 36 into 10 to the power of 5 joules. Or I can write this as 3.6 into 10 to the power of 6 joules. This is a short, pakka 2 marks question. Relationship between kilowatt hour and joule. 1 kilowatt hour is equal to 1 kilowatt into 1 hour. Why we need to convert it into watt in second? Because joules is equal to watt into second. So 1000 watt into 3600 seconds. That is nothing but 36 into 10 to the power of 5 or 3.6 into 10 to the power of 6 joules. Clear? So this is all about what? Power, and this finishes. your chapter on electricity. Okay, so this much, but we still have to do what? In text question, problems based on Joule's law of heating, problems based on power. So it will take hopefully this week till we finish everything. So this is the last part of electricity, where we study what? Commercial unit of electrical energy. The commercial unit of electrical energy is kilowatt hour. All our electricity bill comes in units. So 1 kilowatt hour is equal to 1 unit. So if I consume about 400 kilowatt hour or 40 kilowatt hours, that means I have consumed how many units of electricity? 40 units of electricity. So 1 kilowatt hour is equal to 1 unit. Relationship between kilowatt hour and joule: 1 kilowatt hour is equal to 1 kilowatt into 1 hour. 1000 watt into 3600 seconds. Why I need to do this? Because joules is nothing but watt into seconds. So I get 3.6 into 10 to the power of 6 joules. So today what we studied practical applications of Joule's law of heating. The practical applications of Joule's law are: most of our electrical devices work on Joule's law of heating. In bulbs, a part of electrical energy is converted into heat and light energy. Fuse is used as a safety device. It is always connected in series. If unduly current flows through it, the fuse wire gets heated up and it melts, thus preventing other electrical appliances from getting damaged. Okay? Power is heat energy per unit time or electrical energy per unit time. It is measured in watts. 1 watt is defined as when 1 ampere of current flows through a cross section of a conductor having a potential difference of 1 volt, it establishes a power of 1 watt. We have 4 formulas of power. P is equal to E by T, P is equal to VI, P is equal to I square R, and P is equal to V square by R. Depending on what is given in your problem, you will use the formula. If potential difference is given and current is given, you will use P is equal to VI. If potential difference and resistance is given, you will use P is equal to V square by R. If current and resistance are given, you will use the formula P is equal to I square R. The logic that which formula to use I do not know does not help, because you are supposed to go through everything. Okay? So this finishes your theoretical part of electricity. We need to continue studying the in-text question in page number 218, question Joule's law of heating. Okay? Which we will do tomorrow. Thank you.